Today's topic is functions, and more specifically, we're going to be determining the domain and range of functions and using function notation. So first, let's kind of go back and revisit what a function and even more general, a relation is. A relation is this a rule that shows relationship between numbers where we have input, which are usually x values, and an output, which are usually y values. So an example of a relation could be these three ordered pair: 2, 4, -1, 3, and 2, 7. So that means 2 is related to 4, -1 is related to 3, and 2 is also related to 7. So the input value of 2 is related to the output values 4 and 7. Now, a function is a relation where each element or value in the first set is related to exactly one element or value in the second set. So in other words, when we're talking about ordered pair or inputs, you can't have a repeated x value. You can have repeated y values, but we can't have two repeated x values. So this relation up in example 1 would not be a function because 2 is repeated. Now this would be a function 4, 11, 2, -4, and 1, 11. It is okay for the y's to repeat, but the inputs or the x's cannot. When we look at domains, and we've talked about this a little bit before, there are two things we want to think about. Right, so remember the set of all x values where the function is defined as your domain. So we ask ourselves, what values can x be? Is there anything we can plug in for x that's going to give us a non-defined result? So one of the things is that we can't have a 0 in the denominator. Can't have 0 in the denominator. The second thing is we can't take the even root of a negative number. Can't take the even root of a negative number. Okay, that's not allowed. Range is a set of all y values of the function is defined, and we ask ourselves, is there any values we can't get by plugging in x values? So we plug in all these x values and we can't get certain y ones. For example, y equals x squared, we can never get a negative y value if our function is just y equals x squared, because no matter what number I plug in or what value I plug in for x, we're not going to get a negative answer. So that's what we have to think about with range. Now, function notation, a lot of you are familiar with that. Y equals 5x minus 3 and f of x equals 5x minus 3. They mean the same thing. We can have g of x, s of x, t of x. They all mean the same thing. Now we have, with function notation, f of 3, this is how we say this. F of 3 means plug in 3 for all x values and simplify. It's also known as evaluating a function at x equals 3. This, though, f of x equals 3, what we have to ask ourselves, or what that means, is what value of x gives us an output or a y value of 3? Or when does the function equal 3? So we set the function equal to 3 and solve. As different as these look and as they sound as we talk about them, this is one of the most common mistakes students make when it comes to function notation. Because when they see this, f of x equals 3, a lot of them will start just plugging 3 in for x and getting the wrong values. So for example, let's let f of x equals 9x squared minus 11. F of 3 means we're going to plug in 3 for x. Order operations say do exponents first, so 3 squared is 9. So we have 9 times 9 minus 11. 9 times 9 is 81, minus 11 is 70. And then f of x equals 25, so we're going to set our function equal to 25 and solve. So add 11 to both sides, 9x squared equals 36. Divide both sides by 9, x squared equals 4. And then when we square root both sides, because we are solving an equation, x would equal plus or minus 2. So it was different than plugging in 25 for x, because it says f of x equals 25. We said the function equal to 25. Now letter C says f of x plus h. So what that means is whenever we see an x in our function, we replace it with that x plus h. So what that would look like, it'd be 9, but instead of writing x squared, we're substituting that in for x plus h squared minus 11. And now we have to simplify. X plus h squared, we're using that shortcut for expanding. That becomes x squared plus 2xh plus h squared. And then we can distribute that 9. So 9x squared plus 18xh plus h squared minus 11. Now we can't combine any of that because those are all different terms. We have x squared, we have x and h, we have h squared, and then we have our constants, negative 11. So we can't do anything further. That's our final answer. Now the domain of the function, we've done some of these before. Just kind of want to revisit that. So g of x equals negative 3x squared plus 4x plus 5. There's nothing. We can plug in any x value. We can plug in negative values. We can plug in positive values. We can plug in fractions. So the domain will be negative infinity, comma infinity, or we can do that or write out all real numbers. Example B, f of x equals 1 over x plus 5. Well, we can't have the denominator equal to 0. So you don't always have to write it out like this. For simple ones like this one, where we can see that, oh, what makes the denominator 0? Negative 5 does. So our domain is that x cannot equal negative 5. Now, letter C is where it gets a little bit dicey. We have an even root, and we know that the inside of the even root can't be negative, so it has to be greater than or equal to 0. So then we'll solve this. 3x is greater than or equal to 6, and we divide both sides by 3. We get x must be greater than or equal to 2. So then in interval notation, that looks like this, 2 comma infinity, but we should have a bracket around the 2 because it's greater than or equal to. Then letter D, we can't have the denominator equal 0, so x squared minus 2 equals 0. Add 2 to both sides, we get x squared equals 2. And then when we square root, we get x equals plus or minus the square root of 2. So our domain is x can't equal that. X can't equal plus or minus the square root of 2. That would give us our domain. Notice for these rational functions here, we did not worry about the numerator at all. Even if there was a variable in there, we still wouldn't worry about them. Domain only has to deal with the denominator. So the last thing we'll talk about are what's called piecewise function. A piecewise function is a function that is made up of pieces of another function. And it looks like this. We have f of x equals, and we have two functions listed. We have negative x plus 2 and 2x minus 11. And over here tells you when to use each function. So if my x values are less than 0, I use the top one because it says here x is less than 0. I would use that top one. If x is greater than or equal to 0, I would use this bottom function. So to find f of negative 2, well, negative 2 is smaller than 0, so I'm going to use the yellow function. So negative x, negative, and x is negative 2 plus 2. Well, negative 2 is positive 2 plus 2 is 4. Now, f of 6, 6 is bigger than or greater than 0, so I'm going to use the second function. So f of 6 would equal 2 times 6 squared minus 11. So 6 squared is 36 times 2 is 72 minus 11 is 61. And last one, f of 0. Well, the blue one says x is greater than or equal to 0. So we're still going to use the bottom one. 0 squared is 0 times 2 is 0 minus 11 is negative 11. So that would be our piecewise function and defined at different values. That tells you over here, like I said, which to use for which function. So thanks for watching the video. Hopefully this is a good introduction into what we're going to be doing this chapter in pre-calculus. So make sure to like this video and subscribe.